Assalamualaikum to Safari, our lecturer. Today I'll be presenting about my project, my second project, which is regarding DMP 40022 Design and Assembly Manufacturing. Here is my table of content. The first content will be introduction, which is followed by part to be studied, which is then followed by general shape, attribute for original part and for new product. Next is the process that will be eliminated for every attribute, the final process, and the suitable material. So for the introduction, DFMA, or Design for Manufacturing and Assembly, is a collection of guidelines of two other guidelines which are designed for manufacturing and also designed for assembly. But for this presentation, I'll be focusing on DFM, which is Design for Manufacturing. So DFM focuses on improving the design of the part in order for industries to manufacture the part, and it aims to lower the cost and reduce the time of producing the part. So in this project, I am charged by the lecturer with selecting a part that was redesigned from a previous report or project and find the most suitable process to produce said part. So here is the part to be studied. So this part, which was taken from a previous project, is called a buzzer. It is most commonly used for as an alerting mechanism that is connected to the electronic motherboard to alert the users of any incoming call. So this part is most commonly found in telephones or maybe the modern smartphone. So the buzzer itself consists of copper wire, a battery, nails, and an electric buzzer, whereas the shell is only a thin plastic that can be shaped into many forms. So the part has many common parts that is most commonly found throughout the world, and the outer shell is easy to produce with a process that I will explain later. So here are the general shape attribute for the original design. So firstly, we have depression or depress, uniform wall, uni-wall, uniform cross-section, axial rotation, regular cross-section, capture cavity, enclosed cavity, and draft-free surfaces. So for depression, it means there is recessive surfaces on the part, meaning there is a lower level compared to a uniform level. And there is two categories. One is for one direction, and the second category is two direction. Uniform wall is easily said that the outer wall of the part is uniform. Uniform cross section is when you cut the part into pieces, the part will remain the same shape, or the two parts are both the same shape. Axial rotation meaning that the part can be produced by turning. Regular cross section meaning that the part has a familiar shape such as a circle, hexagon, and such. And capture cavity meaning that the inside of the part is hollow and there is a hole leading to the hollow part. Enclosed cavity meaning the inside the part is hollow but it is entirely enclosed. And draft-free surfaces is when during production the part will not leave any drafts. So for the original design, depress is yes, uni-wall, uni-sec is no, axial rotation is yes, regular cross-section, captured cavity, enclosed, and no draft is no. Whereas for the new design, the depression is yes, uni-wall, uni-sec is no, axial rotation is yes, regular cross-section is yes, capture cavity, enclosed, and no draft is no. So we will now enter the part where I will eliminate processes for every attribute. On the left, the picture shows all the available processes and the material and what is compatible with the attributes. yes. If the attribute has a yes, then we will have to remove the attribute with no. But if it's no, then we have to remove the processes with the letter M. So for the old design, I've essentially removed processes like rotational molding, blow molding, and sheet metal thermoforming and metal spinning. Whereas for the new design, it is essentially the same, as not much of the attribute is different. So for the final process and the selected material, for this part I have selected injection molding as the chosen process, and uh, and I have chosen this process because the selected material for this part is thermosets. This part is required to be made of plastic, as metal would not fit well in a plastic product. Also, it needs to have a certain melting point and a certain ability to mold into any shape that we want. And after the material cools down, it has the hardness to handle blunt hits from any incoming hits. So that is all for my presentation. Thank you for listening.